Hello everyone. Now let's talk about the syntax analysis phase. The syntax analysis phase or syntax analyzer is also called as parser. Okay? So you have to remember that parser is nothing but syntax analyzer, and it is the second phase of compiler design. This parser is classified into two types. First is the top-down parser (TDP) and second is the bottom-up parser (BUP). Top-down parser again further classified as a top-down parser with full backtracking. Means you have to do exhaustive search here, and whenever we talk about exhaustive search, then there is a method called brute force came up into a picture. So brute force is used to do exhaustive search. Means you have to find every possible way in which a particular string of a grammar is generated. And in brute force method, the complexity is big O of 2 power n, which is very huge. So generally we avoid brute force method for parsing process. The second top-down parser is top-down parser without backtracking. So here the good thing is we have not used brute force method, and we can easily parsing the grammar using this top-down parser without backtracking. In top-down parser without backtracking, we have two methods available. First is the recursive descent method and second is the non-recursive descent method. Non-recursive descent method is also called as LL1 parser. Okay, so it is called as a LL1 parser. So recursive and non-recursive descent means, in recursive descent we call for every variable or terminal of a grammar we call a function, or we call a function to implement the particular grammar. But in case of non-recursive descent, we generally not call for every variable a function. So here for every variable we call a function, and in this particular non-recursive descent we not generally not call a function for every variable. Okay. The second classification is bottom-up parser. Bottom-up parser is further classified into operator precedence parser. Operator precedence parser is used generally for mathematical calculations or mathematical precedence and associativity rules. And the second is LR parser. LR parser are of four types. First is the LR0 parser, then SLR1, then LALR1, and then CLR1. Okay, and in LR0, SLR1, LALR1 and CLR1, the power is from LR0 to SLR1. Means LR0 is the least powerful, then SLR1, then LALR1, and CLR1 is the most powerful parser. Okay, bottom-up parser is also called as shift reduce parser. Shift reduce parser. Shift means push and reduce means pop. So we are using a stack to implement these different parsers, and here whenever we shift a particular item, then generally we push, and whenever we reduce an item, then we taken as a pop. Okay, in this particular parser, the operator precedence parser allows ambiguous grammar also. So ambiguous grammar is only allowable by operator precedence parser, and all the above parser TDP without backtracking and LR parsers does not allow ambiguous grammar. Coming to that TDP without backtracking, it will not allow LL1. So LL1 here is not allowed, and it will not allow left recursive grammar. Means left recursive grammar. It will not allow left recursive grammar. Okay. So we will take first from recursive descent parser, and then we will further cover all these parsers one by one. But you have to be remember that before understanding the parser topic, you have to go through the grammar topic. which I have discussed earlier. So in grammar I have discussed left recursive, right recursive grammar, then deterministic and non-deterministic grammar, and the ambiguous and unambiguous grammar. So this concept is required here to understand the parser, all the parsers. Okay, so let's discuss one by one. First we have to go through the recursive descent parser. Okay, so in the next video we will discuss recursive descent parser.